This is section 8.2a, matrix operations. The first matrix operation that we're going to cover is matrix addition. So to add matrices, first you check to see if the matrices have the same order, because matrices of different orders cannot be added. Second, you add the corresponding entries. So let's look at this example. Find the sums a plus b and b plus c. For the matrices, a equals 1, 5, 2, 1, 0, 6, b equals 2, 0, 6, negative 1, 0, negative 3, c equals 3, negative 3, 0, 3, 2, 4. Well, looking at a and b, which is the first sum we're asked to find, we can see that they're not of the same order, and therefore you can't add a and b. A has order 3 by 2 and b has order 2 by 3, so they cannot be added. Now, b and c, however, do have the same order, and thus they can be added. And the way you add matrices is you simply add corresponding entries. So b plus c equals 2, 0, 6, negative 1, 0, negative 3, plus 3, negative 3, 0, 3, 2, 4. And adding the corresponding entries, we get the matrix 5, negative 3, 6, 2, 2, 1. Now, what do we mean by corresponding entries? Well, obviously those are entries that have the same row and same column. Alright, so in matrix B, let's start with the number 2 in matrix B. That is first row, first column. So we add it to the corresponding entry in matrix C. And the first row, first column element of matrix C is 3. 2 plus 3 is 5. And we can continue that process with each corresponding entry, going from left to right. Now we have 0, first row, second column of B, plus negative 3, first row, second column of C, equals negative 3. 6, first row, third column of B, plus 0, first row, third column of C, equals 6, and so on. So that's matrix addition. Now, matrix addition is the name of this operation, but it actually includes subtraction. And the simple reason for that is that subtraction is really just the same as adding a negative number. So just a little point of terminology to remember. When we're talking about matrix operations, matrix addition includes subtraction of matrices. We don't give it a different name, matrix subtraction. So that's why the title of this screen is still matrix addition, but now we're going to learn how to subtract matrices. And it's very similar because it's basically the same operation. First, we check to see if the matrices have the same order. If they don't, they can't be subtracted. And second, we subtract corresponding entries. And that's really equivalent to adding the negative. Subtraction is really just adding a negative. For example, find the differences a minus b and b minus c for the matrices a equals 3, 7, 2, 1, b equals 2, negative 1, 4, negative 5, and c equals negative 1, 5, 1, 2, 1, 6. Let's look first at a minus b. Well, a and b are of the same order, thus they can be subtracted. They're both of order 2 by 2. And when I subtract corresponding entries, I get a minus b equals 3, 7, 2, 1, minus 2, negative 1, 4, negative 5, equals the matrix 1, 8, negative 2, 6. Alright, you can easily follow the corresponding entries. Let's just go in order. 3 minus 2 is 1. 7 minus negative 1 is 8. 2 minus 4 is negative 2. 1 minus negative 5 is 6. Now, B and C are not of the same order. Since B is of order 2 by 2 and C is of order 3 by 2, they cannot be subtracted. The next matrix operation that we're going to talk about is called scalar multiplication. Scalar multiplication. If A equals Aij is an m by n matrix and C is a scalar, a real number, then the m by n matrix Ca equals Caij is the scalar multiple of A by C. Now that sounds complicated, but it's actually quite simple. First of all, let me explain why they call it a scalar. Because it scales the matrix. Like, for example, a Hot Wheel car is 1/64th of a real car. That's the scale of the Hot Wheel model. It's 1/64th. You could look at it the opposite way, and you could say that a Hot Wheel car is standard size, and real cars are 64 times of Hot Wheel car size. It's just a matter of scale, and so we call this scalar multiplication, because we multiply a matrix by a number that scales it. Example, find 2a and negative 3a for a equals 2, 5, negative 1, 3, 4, 0, 2, 7, 2. Alright, so we have matrix A, and we're going to perform scalar multiplication on it. First, we multiply that matrix A by 2. 2a equals 2 times every entry. Alright, that's why the 2 is in red, and that red 2 simply indicates the scalar. And since we're scaling the whole matrix, well, everything gets multiplied by 2. Everything gets multiplied by 2. It's kind of, think of it this way: if you have a model, and that model has length, width, and height, and you want a replica that is 3 times that model, well, you need to multiply the length by 3, the width by 3, and the height by 3. Alright, so that's just to emphasize this idea of scaling a matrix. We just multiply all the entries by the scalar. So 2a equals 4, 10, negative 2, 6, 8, 0, 4, 14, 4. Negative 3a. Now, you should pause the video, do this on your own, and resume when you have an answer for negative 3a. We just multiply every entry by negative 3, and we end up with the matrix negative 6, negative 15, 3, negative 9, negative 12, 0, negative 6, negative 21, negative 6. Another example, calculate the value of 3a minus 2b plus c with matrix A 2, negative 1, 3, 5, 4, negative 2, matrix B 5, 2, 1, 0, 3, negative 1, and matrix C 5, 2, 1, 0, 3, negative 1. Now, you should recognize that we're going to get a scalar multiple of A, multiply A by the scalar 3. We are going to subtract then the scalar multiple of B, multiplying B by 2, and then add it to C. So you do know enough to do this, to perform these operations. For practice, you should pause, perform the operations, and then resume when you have an answer. Here is the answer then, going through it step by step. 3a minus 2b plus c equals 3 times matrix A minus 2 times matrix B plus matrix C. And then we perform the appropriate scalar multiplications, and then we combine them all with subtraction and addition using the corresponding entries, and we end up with the final matrix of 1, negative 5, 8, 15, 9, negative 5. That's the matrix on the bottom right corner there. 1, negative 5, 8, 15, 9, negative 5. Another example, we are going to solve for the matrix X in the equation 2x minus 2a equals b. So now we're going to see how to do a little bit of algebra with matrices. So we have matrix A and matrix B. Matrix A is 2, negative 1, 3, 5, 4, negative 2. Matrix B is 5, 2, 1, 0, 3, negative 1. And we see that we are trying to solve for x. So first you just do the algebraic steps, and then you worry about the matrices. So notice the next few steps that I've done for you under the matrices. First, 2x minus 2a equals b. That's the equation we're given. We want to solve for x. Next step, algebraically, is simply 2x equals b plus 2a. And then we want to get x by itself, so we multiply each side by 1/2. X equals 1/2 b plus a. Alright, now that's something we can work with, because we know b, we know a. And if we perform these operations, 1/2 b plus a, then we can come up with the matrix X. So pause the video, find matrix X, and then resume when you have it. X equals 4.50, 3.55, 5.5, negative 2.5. And you should have come up with that answer. The classwork, page 597. Write these down and we'll work on them in class.